Hello everyone, welcome to an algebra tutorial video learning about domain and range of exponential functions. I wanted to go over another example of finding domain and range, specifically one that involved a vertical translation. Just so you can see how changing that little bit, that moving it up or down, changing the asymptote, what our function approaches, has a big effect on how we describe the domain and range. So here we go. We've got the function f of x equals 38 times 0.9 to the x power, but then we have a vertical shift where we're going to subtract 8 from the entire function. And here you can see the table of values and the graph. Both are all representations of what is going on with this function, and it starts big, slows down and seems to decrease and decrease, and then sort of flattens out. And you can see by looking at the table, it's approaches -8, right? It's going to get very close to -8 because I subtracted 8 from the function, but it's never ever going to quite reach it. Even though it shows at this value of 90, it's got a value for y of -8. That's just rounding it for the graph's sake. It really is -7.9971053. And if I keep going, it's going to get closer and closer and closer and closer, infinitely closer, -7.9999999, but I will never ever make it equal exactly 8. All right, so how does that affect domain and range? Well, in terms of my domain, we've talked about the fact that the domain of exponential functions is always all real numbers. I can put anything in for x into the function here, and I'm always going to get a value. I can make x huge, I can make x small, I can make x a fraction, I can make it a decimal. I can put any specific number as long as it's a real number, and it's something I can calculate. I can figure out, well, 38 times 0.9 to whatever that number is, I'm going to get a result. So this is another example. All real numbers, I can put anything in for x and get a value back from my function. Later on, we're going to look at functions that have interesting domains and that don't work for all real numbers, but for exponential functions, domain is always all real numbers, all x values. All right, the range is where we get interested. So for the range, that's all the possible y values, right? So I'm very interested in the y-axis and what values I get back as I put in x values. So you can see I'm getting positive. It increases this way. So I can get as big as I want in my y values. And if I go towards -x, I can keep getting bigger and bigger and bigger. We can see that in the table. I can see that in the graph. But when I go towards the right with my x values, my asymptote, my line, is right along here. And it approaches -8. So I have an asymptote, a line that kind of gives me a boundary at a y value equal to -8. That asymptote means that it's never going to equal -8 and it's never going to get below -8. So if I'm describing all the possible y values that work, it's all real numbers, but in this case they have to be greater than -8. So it is possible to get, for example, like -5. I can look that on my graph and say -5 is right here. And if I go over, I would say I will get -5 if I input a value of right about there, right about 25. So I can get some negative values in this case. I just can't ever get a y value that's less than -8. So that's why my range is all the real numbers, but they have to be greater than -8. So hopefully that makes sense to you in terms of domain and range for this particular exponential function, and how vertical shifts make a big difference in how we describe the range.